Now let us obtain the parameters of Horton's infiltration capacity equation to represent the following data. Also plot the curve of infiltration capacity versus time. We'll be using this equation. It is the Horton's infiltration equation. Fp is equal to Fc plus F0 minus Fc e raised to minus kT. Fp is the infiltration capacity at any time t. F0 is the initial infiltration capacity. Fc is the final steady state infiltration capacity, and K is the Horton's decay coefficient, which depends upon soil characteristic and vegetation cover. So the time since the start of infiltration is given 510 up to 130 minutes, and cumulative infiltration depth is also given. Time interval 5 minutes, 10 minus 5. Let me drag this down. Incremental depth in the given time interval is 1.75. 3 minus 1.75, and so on. Infiltration rate is equal to, we need infiltration rate in centimeters per hour, so 1.75 in 5 minutes divided by 60. So this is the infiltration rate. So final infiltration rate is obtained after 110 minutes, 110 minutes. At 130 minutes, infiltration rate is not changing. So we'll take this as the final steady state infiltration rate. ln Fp minus Fc, will need this to obtain parameters of Horton's infiltration equation. So ln Fp is this value minus Fc is 3.24. Time in hours. So 5 minutes by 660, 0.083, and so on. Now let us first plot the curve of infiltration rate and time. Infiltration rate versus time, and cumulative infiltration depth versus time. Time on the x-axis. Sorry. Infiltration rate and cumulative infiltration depth. So this curve represents the infiltration rate, and this curve represents the cumulative infiltration depth. We can plot this on secondary y-axis. So this represents cumulative infiltration depth values, and this curve shows the infiltration rate. This axis shows the value of infiltration rate. Now let us obtain the parameters. Now to obtain the parameters of Horton's infiltration equation, we'll need to carry out some initial procedure. Fp minus Fc. From this equation, Fp minus Fc is equal to F0 minus Fc into e raised to minus kT, taking a log on both sides. So ln Fp minus Fc is equal to ln F0 minus Fc minus kT. So we'll be plotting the graphs of ln fp minus fc versus t. And from that, we'll obtain an equation and we'll compare that equation with this equation to obtain the parameters. So time ln fp minus fc, we've already calculated this. Fp minus fc, sorry, paste values. We'll add the trend line. Also, we'll add the equation and display r squared value on chart. So this is the equation. Y is equal to minus 2.6751 into x plus 2.8868. Now the slope is represented by k here. So k is equal to the slope, which is 2.6751. Now ln f0 minus fc, ln f0 minus fc is the intercept. So it is obtained by substituting the value of x as 0. So we'll obtain the intercept value as 2.8868. So ln f0 minus fc is 2.8868. So f0 minus fc will be equal to, taking the antilog, so 2.718, which is the value of E, 2.718 raised to this value will give us the value of f0 minus fc. f0 minus fc is equal to 17.93. We obtain this f0 minus fc. fc is, sorry, f0 is equal to 17.93 plus fc, which is the final steady state infiltration capacity. It is 3.24 plus 3.24. So value of f0 has also been obtained. So our final equation is fp is equal to fc plus f0 minus fc e raised to minus kt. We'll substitute these values. So fp is equal to 3.24 plus 17.93 e raised to minus 2.6751 into t. This is the final Horton's infiltration equation. Fp is equal to 3.24 plus 17.93 e raised to minus 2.6751 into t.